Hi guys, so first of all, I would like to introduce myself. I am Brian A. Salvador of 1IA, currently studying at Pamantasan ng Kabuyao or PNC. So this video is all about the evolution of operating system. First of all, what is operating system? Commonly known as OS, is a system software that manages computer hardware, software resources, and provides common services for computer programs. Also, OS acts as an intermediate between hardware and user. So, after all those meanings, for better understanding, I will show you a graphical representation of how OS or operating system works between users, us, and the computer. As you can see from the picture, the OS is found between the user and the hardware, meaning the OS or operating system translate what the user wants to the hardware. Now that we know how the operating system or OS works, we will now discuss how the ENIAC evolved from the present-day Microsoft. Do you know that there are 8 phases of how operating systems evolve? No? Then I will tell you what those 8 are. Those 8 phases of evolution of operating systems are as follows. The 8 phases of operating system evolution. It all started with nothing. Simply put, phase 0 or the no operating system. So now we start with phase 0 or the no operating system. Back in the days from 1940s to 1950s, computers are exotic and experimental. Programs are written in machine language. We use plug boards to direct computers. There's no overlap between I/O, the input and output, and the response time and tick time. Programs are manually loaded via deck cards. Just look at this card. Back in the days, computers are large and hard to operate. Just look at this guy right here. So now, after all that, here are some examples of phase 0 computers. Complex Number Calculator, CNC. Built by the Bell Telephone Laboratories, it is designed by George Stibitz. Bombe, 1941. Used to decrypt Nazi Enigma-based military comms, designed by Alan Turing and Harold Keen of the British Tabulating Machine Company, a Tanasov Berry computer, or ABC. The first automatic electronic digital computer made by the Iowa State College. Now, before we go to the next phase of the evolution of operating system, there's some additional knowledge I want to impart with you. Do you know that back in September 9, 1947, Grace Hopper's records what she jokingly called the first actual computer bug? In this case, a mat is stuck between the relay contacts of Harvard Mark II computer. Now, for the next phase of the evolution of operating system, the phase 1 or the batch system. The batch system makes more efficient use of the computer, move the person away from the machine. User console is one user at a time. The OS becomes a batch monitor, a program that loads a user's job. Here's some advantages and disadvantages to the batch system. Advantages to the batch system. 1. More efficient use of hardware. 2. Efficiency increases because it processes the jobs as a batch. Disadvantages to the batch system. 1. No protection. 2. Difficult to bug. Now here is a graphical representation of how batch system works. Example of batch system. DOS 360. Discontinued first member of a sequence of OS for IBM System 360. Now that we're finished with the phase 1 of evolution of operating systems, we will now move on with the phase 2, which is the multi-program systems. Multi-program systems allow to execute multiple processes by monitoring their process states. They never let the CPU idle by and also creates logical parallelism. Here are some advantages and disadvantages of the multi-program systems. Advantages of multi-program systems. 1. Increased CPU utilization. 2. Resources are utilized smartly. 3. Multiple users can use the system at once. Disadvantages of multi-program systems. CPU scheduling is needed. 2. Memory management is required. 3. If it contains massive loads of jobs, then it takes a long time. Examples of multi-program systems. MPM. Discontinued multi-user version of the CPM operating system. Created by digital research developer Top Rolander. Xenix. Discontinued version of the Unix operating system for various microcomputer platforms. Now that we're finished with the phase 2 of the evolution of operating systems, we will now move on with the phase 3 or the time-sharing system. The time-sharing system shows interactive time-sharing. It is developed at MIT or the Massachusetts Institute of Technology. Users do the debugging, editing, and email online. So after all that, here are some advantages and disadvantages to the time-sharing system. Advantages to the time-sharing system. 1. Better utilization of resources. 2. More than one user executes their task simultaneously. 3. Decrease paperwork and CPU idle time. Disadvantages to the time-sharing system. 1. Thrashing. 2. Creates reliability issue. And 3. Less security and data integrity. Now here is a graph of how the number of users affect a time-sharing system. Examples of time-sharing system. Unix began life as a mini-computer time-sharing system designed by D.M. Ritchie and K. Thompson. Linux provides time-sharing environment to processes. Now that we're finished with the phase 3 or the time-sharing system, we will now move to the phase 4 or the teleprocessing system. Here, instead of using specific wiring, companies use conventional telephone lines. There's also the use of the modem or the modulator and demodulator to transmit information using those telephone lines. The combining of telecommunications and computer operations interacting in the automatic processing, reception, and transmission of data and or information. Now, here is a graphical representation of how teleprocessing system works. All computers are connected and sharing information through a central hub using telephone lines. Example of teleprocessing system. Customer Information Control System or CICS. Used for IBM mainframes introduced in July 1969, which can process thousands of transactions per second. So now that we are finished with the phase 4 or the teleprocessing system, we will now move on with the personal system. Here, the personal system, the operating system or OS becomes a subroutine library. Also, this is where the GUI or the graphical user interface was developed for the first time. Also, personal systems provide a good interface to a single user, and it is widely used for word processing, spreadsheets, and internet access. There are some modifications in the personal system, which is, just like I've said, OS becomes a subroutine library and a command executive. Also, with the invention of the GUI, the OS allows accessing hardware without writing programs. See, the evolution from batch system to the more common personal system. The operating system has now become more user-friendly than ever before. So now, here are some examples of the personal system. Examples of personal system. Macintosh OS. Developed by Apple, includes GUI-based OS. It has designed for use with its Macintosh series of PC since 1984. Windows version 1.0. Graphical operating environment for personal computers, developed by Microsoft. Now that we are now finished with the phase 5 or the personal system, we will now move on with the network system, simply the phase 6. The phase 6 or the network systems enables different machines to share resources like printers, file servers, and web servers. Its uses are for computing and file storage. So after all that, I'm going to tell you some advantages and disadvantages to the network system. Advantages to the network system. Centralized servers are highly stable. Number 2, security is server managed. Number 3, possible to remote access to servers from different locations. Disadvantages to the network system. Number 1, high cost of buying and running a server. Number 2, dependency on a central location for most operations. And number 3, regular maintenance and updates are required. Examples of network system. Microsoft Server. Produced by the Microsoft, is a brand name for a group of server operating system made by Microsoft. Linux. An ideal, typically offering enhanced permission, increased flexibility, and stability. Now that we are finished with the phase 6 or the network system, we will now move on to the last evolution of operating system, which is phase 7 or the mobile OS. The mobile OS is a software that allows smartphones, tablet PCs, and other devices to run applications and programs. The mobile OS typically starts up when a device powers on, presenting a screen with icons or tiles that present information and provides application access. Do you know that there are two most widely adopted of mobile OS? Those are the Android and the iPhone or the iOS. So before all that, here are some examples of other mobile OS. Examples of mobile systems. Android. Android is still the best OS. Android OS is an open source project that gives the users lots of options. iOS. The mobile OS of Apple and is very famous for its hardcore system. Works very well, even better than the Android. The only lacking points is iOS is not that very customizable. Sailfish OS. A Linux-based mobile operating system which is targeted for the smartphone. Great security system. And OS also has low power consumption. And those are just some examples of mobile operating system. Unfortunately, that's the end of the journey of the evolution of operating systems. I hope you learned something today and thank you for watching.